Right, we have here this particular limit of a multi-variable function. So we need to evaluate the limit of y over x as x and y tend to 0 and 0. We present a solution to this particular problem, but in a step-by-step fashion as follows. Right, so we need to evaluate the limit of y over x as x and y tend to 0 and 0. Now, we can approach the origin 0 and 0 in several ways, and we're going to choose and we're going to perform limits along curves. Right, so we're going to approach the origin along, for example, curve C, and we can approach the origin along curve D, either from above or from the bottom or from below. So we're going to do this along. Right. So we're going to approach the origin along curve C. And what is curve C? Curve C is y equals x. So that we have here the limit as x and y tend to 0 and 0 of y over x. And this is equal to, right, so now the couple of things we need to consider here. And we need to realize that along curve C, we put the small c here, like at the bottom, okay? So, so that wherever there is y, we can substitute and put y equals x. So that now we have x and x approaches 0 and 0, and this means we have the limit as x tends to 0, okay? Because you substitute y by x, and therefore you have x and x approaches 0 and 0, which means x approaches 0. And then wherever there is y, we put x over x. Right, in which case, therefore, you have the limit as x approaches 0 of 1. And this limit is 1. Right, so in other words, this limit here is exactly 1. And we have seen that the limit along curve C is 1. Then we're going to perform and do the limit along curve D, the y equal to minus x curve. Okay, along curve D, which is y equals minus x. Right, what do we have? We have the limit as x and y approaches 0 and 0 of y over x. And this is the limit. Okay, so this is along curve D, so you put a small d there, but y equals minus x. So wherever there is y, you substitute with minus x, and therefore you have x, the first component, x approaches 0, the second component, minus x approaches 0. So in other words, you can write like this. X, wherever there is y, you put minus x. And this approaches 0 and 0. But wherever there is y, you have minus x over x. Okay. So you have this approaches 0. Okay, the first component approaches 0. The second component also approaches 0. So you have minus 1 here. And this result is minus 1. Okay, so the limit along curve D is minus 1. Note that. And also we have that the limit along curve C is also 1. And so because of this, the fact that these two limits are essentially different, okay, we conclude and say, hence, right, hence, the limit as x and y approach 0 and 0 of y over x does not exist. Does not exist since the limit of as x and y approach 0 and 0 along curve C is not equal to the limit as x and y approach 0 and 0 along curve D. Right, so we have seen therefore that these two limits are different because one is not equal to -1, and therefore we conclude that this limit does not exist since this is the case, and therefore we are done. However, let's just make a couple of remarks about this. So the curves are not only limited to that, because if you continue, you can look at the plane like this, 0 and 0. And this is y. X is this one. Okay. A couple of things are important for us to consider. We can approach the origin along the normal axis, along the x-axis, along the y-axis. So if you say we need to evaluate the limit, as we saw, right, there are a couple of things you need to think about. So we have therefore that we can choose and say along the x-axis. Along the x-axis. Along the x-axis, we have that y equals 0. And therefore, we can evaluate the limit. And now you can do this. Right, and obviously you can also give, along the x-axis, you can give the x-axis a name and call it a curve. Along the x-axis, then you do curve E. And curve E, along the x-axis, we agree that y is 0 along the x-axis. Right, so we're going to do the limit of y over x, and you have x and y approaches 0 and 0 along curve E. Right, so along curve E, there are a couple of things that are important. Y is 0, but x changes. So, right, so you have the limit. Because y is 0, but x changes, you approach the origin along the x-axis, which means therefore x approaches 0. But y is 0 everywhere on the x-axis. Okay, so now that's something that's very important. So y is 0. So what is this limit here? All right, so this limit here is the same as the limit as x approaches 0. As you approach 0, you are not really at 0, so 0 over x becomes 0, and this limit is 0. Okay, so something very, very important. And It is also a confirmation that indeed, moreover, right, moreover, we infer that the limit of y over x okay, we infer that the limit of y over x as x approaches 0 and 0 does not exist. Since does not exist since, right, you can put the since here. Let's put the since here, does not exist since the limit of x and y along curve C of y over x. This limit is different from the limit as x and y approaches 0 and 0 of y over x, but also this one is along curve D. This is also different from the limit as x and y approaches 0 and 0 along curve E as well. Right, so anyhow, two attempts are enough. Two attempts that show that the limit does not exist. Those are very enough. Okay, so you have therefore that this one here also approaches 0 and 0 along curve E. So we the limit does not exist since these limits are all different. Okay, so this limit does not exist. And we have solved this problem and we've concluded that this limit does not exist, but just two limits that are different are sufficient to show that the limit does not exist. And we are done. Okay, so thanks everybody for watching and your attention, and goodbye to you.